Good morning, students. Today we are going to learn an important topic in pharmaceutics called the heat processes. Heat processes are methods where heat energy is used to remove the moisture, dry substances, purify the materials, or concentrate the solutions. These processes are widely used in pharmaceutical industries for preparing medicines safely and effectively. In this chapter, we will study the different heat processes such as desiccation, sublimation, evaporation, and various types of evaporators. Each process has a special role in drug manufacturing and preservation. For example, when a syrup becomes too dilute, evaporation is used to remove the extra water. When medicines are moisture sensitive, desiccation helps protect them. Similarly, sublimation is used for purification of certain chemicals. So, heat transfer mainly occur through conduction, convection, and radiation. So, these methods helps in transferring the thermal energy from one place to the another. In pharmaceutical industries, heat processes help improve the product stability, increase shelf life, and maintain the quality. So, heat sensitive drugs require a careful temperature control during the processing. So, different evaporators are designed according to the nature of the material. Some are suitable for thick liquids, while others are best for the heat sensitive substances. So, by understanding these concepts, students can easily understand the industrial pharmaceutical manufacturing processes. Today's class will explain every process step by step with diagrams and examples for easy understanding. So let us begin our journey into the world of heat processes. Desiccation. So students, now let us understand the desiccation. Desiccation means the removal of the moisture or water from substance using a drying agent called the desiccant. So desiccator is a closed glass container used to protect the chemicals from moisture in the atmosphere. Inside the desiccator, substance like silica gel or calcium chloride absorbs the water vapor here. So the upper part of the desiccator contains the material to be dried, while the lower compartment contains the drying agent. So the lid is tightly closed to prevent entry of the atmospheric moisture here. So desiccation is commonly used in laboratories and the pharmaceutical industries to keep the medicines dry and stable here. So the moisture can spoil drugs by causing the chemical reactions or the microbial growth. For example, powders like antibiotics absorb the moisture quickly and lose potency. So, keeping them inside a desiccator helps maintain their effectiveness. Another example is effervescent tablets. So, if they absorb moisture, they react prematurely and becomes unsuitable. Desiccation helps reduce the bulk and the weight of the material and improves the storage stability. It is also useful during the experiments where dry conditions are necessary. So, one important advantage is prevention of the bacteria or the fungal growth caused by the moisture. So, thus, desiccation is an essential drying process for protecting the moisture sensitive pharmaceutical products. And next process is sublimation. Now students, let us study the sublimation. Sublimation is a process where a solid changes directly into the vapor without becoming liquid. When the vapor cools, it changes back into the solid form. This process is used to purify the substance that can sublimate. In this diagram, the impure substance is heated in a china dish. The vapors rises upwards and gets deposited on the cool funnel surface as pure crystals. Examples of the sublimable substances includes camphor, iodine, ammonium chloride, and menthol. For instance, camphor tablets slowly disappear in open air due to sublimation. Similarly, naphthalene balls used in the cupboards also sublimate gradually. So, sublimation is used in pharmaceutical industries for purification of chemicals and preparation of certain medicinal compounds. So one major advantage is that impurities remain behind while the pure substance get collected separately. So this process is simple and effective for substances having low melting points and high vapor pressure. So however, only certain substances can undergo sublimation. Non-sublimable substances or materials cannot be purified by this method. So therefore sublimation is an important purification technique in pharmacy and the chemistry. And next process is evaporation. So students, evaporation is one of the most important heat process in the pharmaceutics. So evaporation means the removal of the solvent as a vapor from a solution by applying a heat. Usually water is removed from liquid preparations to concentrate the solution. So the remaining concentrated liquid contains more active ingredients here. So for example, fruit juice concentration, herbal extracts and syrups are prepared using evaporation. So during evaporation, the heat increases the kinetic energy of the molecules, allowing a solvent molecules to escape into the atmosphere as vapor. So evaporation occurs faster at higher temperatures because more molecules gain enough energy to leave the liquid surface. So this process is widely used in the pharmaceutical industries to prepare the concentrated extracts from the medicinal plants. For example, aloe vera extract or tulsi extract is prepared by evaporating excess water. One important point is that the heat sensitive substances require controlled temperature during evaporation, so otherwise the drug may decompose here. So evaporation can be performed using different types of evaporators depending on the industrial needs. So thus evaporation is an essential concentration process in the pharmaceutical manufacturing. Factors affecting evaporation. So now let us understand the factors affecting evaporation. So several conditions influence the speed of evaporation. So the first factor is temperature. So high temperature increases the evaporation rate because molecules gain more energy. For example, clothes dry faster in summer than in winter because of high temperatures. The second factor is the surface area. So larger surface area allows more molecules to escape simultaneously. For example, tea cools faster in a plate than in a cup because the exposed surface area is larger here. The third factor is air movement. Wind removes vapor molecules from the surface and increases the evaporation. So that is why wet cloths dry faster under a fan. So the fourth factor is pressure. So lower pressure reduces the boiling point and increases the evaporation rate here. So the fifth factor is nature of the liquid. So volatile liquids like alcohol evaporates faster than water. So understanding these factors helps the pharmaceutical industries control the evaporation efficiently and safely here. Okay. And next one is the evaporators. So evaporators are the devices used to carry out evaporation efficiently in industries. So different evaporators are designed for different pharmaceutical products. Their main purpose is to remove the solvent and obtain the concentrated products. So evaporators improve the heat transfer and save time compared to the simple open heating. They are classified into natural circulation evaporators, forced circulation evaporators and film evaporators. So selection depends on the product viscosity, temperature sensitivity and concentration required. Some evaporators are suitable for thick liquids while others are suitable for heat sensitive materials. So industrial evaporators are usually made of stainless steel to prevent the corrosion and contamination. So modern evaporators also includes the condensers and vacuum systems for better efficiency. For example, the herbal extracts, syrups and injectable preparations use evaporators during the manufacturing. Thus, evaporators are very important equipments in pharmaceutical industries. So let us see one by one clearly. First start with the evaporating pan. An evaporating pan is the simplest type of evaporator. It consists of a hemispherical metal pan heated by a steam. So the liquid is placed inside the pan and heated until the solvent evaporates. So this method is simple, easy to operate and inexpensive. So it is suitable for small scale pharmaceutical preparations. One advantage is easy cleaning and maintenance. So another advantage is simple construction with low cost. So however, the heat transfer efficiency is low because natural circulation is slow. It is not suitable for heat sensitive drugs because prolonged heating may damage the product. So there is also a risk of decomposition due to uneven heating. Thus, evaporating pans are mainly used for simple and small scale evaporation operations. And next one is evaporating still. So students, an evaporating still is an improved evaporator with a condenser attached. Here vapors produced during evaporation are condensed back into the liquid form and collected separately. So this helps recover the valuable solvents like alcohol. So the apparatus contains a vessel connected to a condenser through pipes. So the liquid is heated, vapors move to the condenser and cooling water converts vapor into the liquid here. So one major advantage is solvent recovery, so which reduces the wastage and cost. So it is useful when expensive solvents are used in pharmaceutical manufacturing. So however, the equipment is more expensive and requires a careful maintenance. So heat sensitive substances may still get damaged if heating is excessive. So therefore, evaporating stills are useful for solvent recovery and purification processes. And next type of equipment is short tube evaporator. Now let us study the short tube evaporator. It contains a short vertical tubes through which liquid circulates naturally. So steam outside the tubes provides heat for evaporation. As the liquid heats up, bubbles forms and rises upwards, creating circulation here. So this improves the heat transfer compared to an evaporating pan. Short tube evaporators are suitable for moderate scale industrial operations. They provide better evaporation efficiency and faster concentration. However, construction is more expensive than simple evaporators. Cleaning the tube may also be difficult. So thicker, highly viscous liquids are not suitable because circulation becomes poor here. So thus short tube evaporators are useful for medium scale pharmaceutical concentration processes. Forced circulation evaporator. So students, forced circulation evaporators use pump to circulate the liquid rapidly through the heating tubes. So this rapid movement improves the heat transfer and prevents the deposition inside the tubes. So these evaporators are suitable for viscous liquids and materials that form crystals. For example, concentrated syrups or thick herbal extracts can be processed effectively here. The pump forces the liquid through the tubes at a high speed, reducing the overheating here. So one major advantage is prevention of scaling and deposition. So another advantage is better heat transfer efficiently. So however, the equipment is somewhat expensive and requires a more power for pump operation here. So maintenance cost is also higher compared to the simple evaporators. So therefore, forced circulation evaporators are mainly used in the large industrial operations. And next one is the climbing film evaporator. So now students, let us understand the climbing film evaporator. In this evaporator, the liquid forms a thin film inside long vertical tubes here. As the heating occurs, the vapor bubbles pushes the liquid upwards, creating a climbing film. So this film provides excellent heat transfer and rapid evaporation here. So the contact time between the liquid and the heat is very short, so making it suitable for heat sensitive drugs. Okay, for example, fruit juices and antibiotic solutions can be concentrated safely here. So one advantage is high evaporation efficiency. So another advantage is it mainly reduces the thermal decomposition due to short heating time. So however, the proper liquid feed control is necessary for efficient operation here. So this equipment is costly and requires a skilled operation. So thus climbing film evaporators are very useful for delicate pharmaceutical products. And next one is the horizontal film evaporator. So students, in a horizontal film evaporator, the liquid spreads as a thin film over horizontal tubes. So steam passes through the tubes and provides heat for evaporation here. So the thin film increases the surface area and improves the evaporation rate obviously. So this evaporator is suitable for heat sensitive materials because heating time is very short here. So it is commonly used in the pharmaceutical and food industries. So one advantage is efficient heat transfer due to thin film formation. So another advantage is rapid evaporation with less product damage. However, cleaning and maintenance can be difficult. The equipment is expensive and requires a careful operation. Thus, horizontal film evaporators are used for efficient industrial evaporations. Multiple effect evaporator. So now let us learn about the multiple effect evaporators. So these systems use vapor from one evaporator to heat another evaporator. So this arrangement saves steam and improves the energy efficiency. In this diagram, the vapors from the first effect becomes the heating source for the second effect. Similarly, vapors from the second effect heats the third effect. So this process generally reduces the fuel consumption here. So multiple effect evaporators are used in large scale industries where energy saving is very important. So one advantage is the economical operation due to steam reuse. Another advantage is high production capacity. So however, installation cost is high and the operation is complex. So these multiple effect evaporators are highly efficient system for industrial evaporation. And next process is the evaporation under pressure. Students, evaporation under pressure means evaporation carried out at pressures different from atmospheric pressure. So when pressure decreases, the boiling point of the water also decreases. So this principle is used in the vacuum evaporation to protect the heat sensitive drugs. For example, water boils at low temperatures under vacuum conditions. So this prevents the decomposition of the sensitive pharmaceutical products here. So the table in the slide shows how boiling point changes with pressure. So lowering pressure results in lowering boiling temperatures. One major advantage is safe evaporation of the heat sensitive materials here. So however, vacuum system increases the equipment cost and the maintenance requirements. Thus, evaporation under pressure is very important in the pharmaceutical industries. Students, today we are learning about the different heat processes used in the pharmaceutics. We studied the desiccation, sublimation, evaporation and various evaporators used in the industries. So each process has specific applications depending on the type of material and industrial requirement. Desiccation removes the moisture, sublimation purifies the substance and evaporation concentrates the solutions. Different evaporators improves the efficiency and save energy. So heat sensitive drugs requires the special evaporators such as climbing film and vacuum evaporators. Multiple effect evaporators help reduce the steam consumption and operation costs. So understanding these processes is essential for the pharmaceutical manufacturing and the quality control here. So these concepts are widely used in the industrial processes during syrups preparation, extracts, injections and herbal preparations. So thank you students for attending this class on heat processes. I hope you understand all the concepts, diagrams and industrial applications explained today. So these topics are very important in the pharmaceutics and the pharmaceutical engineering. So practice the diagrams regularly and revise the advantages and disadvantages of each evaporator. So understanding the working principles will help you in the exams as well as in the practical applications. So always remember that the Correct heat processing improves the medicine quality and stability here. So if you found this class useful, support Medi queries by liking, sharing and subscribing. So your support motivates us to create more educational content for pharmacy students. Keep learning, stay curious and continue exploring pharmaceutical sciences. Thank you once again and see you in the next class.